Well, thank you for waiting to the end. This is the last one, so we're almost there. I'm Chris. I use he, they pronouns. I'm going to be talking about bursting the filter bubble and how to disincentivize echo chambers and social networks. This is joint work with my great advisors, Christian and Jennifer, and our fantastic collaborator, Ellen Vitercik at Stanford University. So like unless you live under a rock, you know that social media platforms and large online platforms are a huge way in which we organize society and play a huge important role in our lives. We use them for communication, idea exposure, community building, mental health resources, democracy, and so many things that we need to run society. However, these platforms, their revenue, their profit is derived from engagement at scale, which leads them to serve like the most addictive content, which is not necessarily the healthiest content or the content that people should be seeing. And so they also use AI-based recommendation algorithms to help like filter, curate, and like target many users. And these algorithms are like have very powerful uses. They help us filter and curate large volumes of content. Like with my Spotify, I'm able to find new music that I would have to do so much more work to do otherwise. Help us discover similar content, which is like facilitate community building, and like many people with shared interests and like coming together. And yeah, so there's powerful tools, but they also have some harmful effects. And so there's a large bunch of literature saying that although this is kind of still in the debate, and it's like not clear how much of this is from the algorithm themselves and the people's incentives, but they can lead to polarization. It's been shown that algorithmic AI-based recommendation algorithms can lead to minority suppression, like algorithmic glass ceilings. They've also been shown to disproportionately spread misinformation and propaganda to minority or vulnerable communities. And so the main question of this research project is to understand whether we can design or improve the recommendation algorithms in a way that preserves all these positive aspects, the curation, the community building, the filtering effect, while avoiding certain pitfalls, specifically filter bubbles and polarization. And so to model this problem, we use a multi-unbranded formulation, which is essentially just a way of like reasoning about decision making and uncertainty and how much to explore versus commit and the trade-offs around that. And so we have end users in K content categories, which could be like fashion, sports, left-leaning news, right-leaning news, cats, dogs, whatever sort of categories of content you have. And for each user, the platform gets a reward, whether it's revenue, time watched, or clicks that the platform gets for showing a user certain content. And so we assume that, and for this distribution, that it's like a random report, and from a distribution for each user, for each content category, and this is unknown to the platform, so the platform has to try and learn these interests and this distribution. We assume that the means are finite, it's just like a technical thing. Yeah, so every T times, that's whether when you log in, whether you go online or Instagram, the platform decides on what content distribution to show you, and then samples content from that distribution. And so they have this like probability vector where each component is the probability of showing to the user a certain content category. And so the platform's goal is to pick distributions that maximize their revenue, their time watch, whatever kind of metric they're using to optimize for. And so the platform has to balance learning these distributions with also getting a good reward along the way. Because maybe when you come on, for the first time, they don't really know what you like, so they're trying to play it safe. But over time, they still want to make money, but they also still want to learn what you actually like. And so you can see how like standard bandit algorithms could maybe lead to these sort of like augmented filter bubbles, because they eventually converge on like one content category and then show you that content continuously, and then you're kind of like siloed into this like filter bubble. And so we want to kind of avoid this problem. And so one way you might go about doing this is like, intuitively, you might want to say that the content that I show a particular user shouldn't be too far off from what I'm showing everyone on the platform, right? And so one way to like mathematically impose this kind of constraint is enforce a distance metric between each user probability vector and like the average overall people on the platform. So let's just define P average as its average vector, and then you just see something like you want the norm between the two vectors to be less than some delta, which serves as a cap on personalization. and hence polarization. But the problem with doing something like this is that you actually have some very nice or some really bad properties of solutions. It turns out that when you do this kind of distance constraint, the burden of diversification is disproportionately given to the minority groups. So what ends up happening is that majority groups just keep on seeing the same thing they've been seeing always, and all the diversity is only what minority interests, minority groups want to see. And that's kind of counter to the spirit of what we're trying to do. In addition, there's actually many ways that satisfy these kinds of constraints that have very different implications for using the platform. So for example, let's say we had a fully polarized setting where there was the same number of content categories as users, and each user only liked one category and no other one. And so from the platform's perspective, we could just pick one user and show everyone that one thing and say that's not polarized, and they'll get 1 over n revenue. But they could also just show uniform across all the different categories, and that would also be polarized. But in one situation, only one user is getting any reward whatsoever, while the other one, even if it's small overall for the platform, each user is at least getting something. So, so you do kind of have to pay attention to these kinds of issues when you're trying to kind of make people kind of come together, at least from a mathematical perspective. So we have this lemma showing that you do indeed get these kinds of tyranny of the majority effects when you do this sort of thing. But on the other hand, you do want to use kind of population interest in some way. You know, as much as I might like cats, it might not be reasonable to have all of LinkedIn's content to that cat content, right? So you do actually want to match what you're doing to sort of the users, the population kind of statistics. And so the intuition between of the approaches that we end up coming to use is that users should primarily see what they're most interested in. So this avoids tyranny of the majority because you're not going to be forced to see something that you really don't like. But on the other hand, users' content should contain some kind of flavor of what everyone is interested in. So I think of this as kind of a town hall where for some days of the week, everyone has to come together. We all talk about our issues in this kind of large group community setting. And then after that, you can go and just have your side conversations, if that makes sense. So that's kind of I'm thinking of the intuition beyond these two things. And so we have two primarily approaches to addressing this. The first one is kind of a personalization cap, where we impose a lower bound on each user's individual probability distributions based on the average. And so this way, you are still seeing what you have to see what a sample of what everyone else is seeing for some everyone else is seeing for some amount of time. And so this gamma parameter shows the cap on the level of personalization. When gamma is 0, you're basically unconstrained, you can still personalize as much as you want. And when gamma is 1, everyone has to get average, it's completely homogeneous in the content that we shown. And so we prove a lemma in the paper that with this kind of constraint, when gamma is the cap, you don't have these kind of tyranny majority effects, and that the burden of diversification is proportionally spread across all the different groups. So at least we're solving some of these kinds of fairness or equity issues. And then another approach is to, instead of having a hard constraint where you're trying to change the content, you might actually want to impose some kind of tax or give a subsidy for exposure or diversity to the platform. And so we basically just turn the old hard constraint to a soft constraint, and then using this function, which basically measures how much we violated a constraint from the previous approach, and then we can either use a parameter to tax the platform, so we say take some revenue, which kind of steers them towards showing more diverse content, and then you have this eta parameter to modulate how much of tax you want to charge. And then if you make this less than 0, and also slightly change the inside of the equation, you can also have a subsidy, which makes them they want to give more diverse content. And so regulators can pick eta, gamma to steer how much they value these things and make the platforms prevent filter bubbles. So another issue though is how do you actually make sure the platform is complying with these kind of constraints if you set that? And so we also think about how to audit the platform and make sure that they're complying with the constraints with the tax. And so, for example, regulators don't have access to true content distribution. They only have a sample of what you're actually showing people. And then the platform might actually want to maybe adjust their strategy or how they show content to kind of hide whether they're polarizing or whether the distribution can change over time. And so you want to kind of, because the regulator can't check every single day what the platform is doing, you have to check an average of a certain time period. So these introduce some issues to actually making sure that you can actually ensure that the platform follows your constraints or is being taxed properly. And so we also address this. And so our main technical results we prove regret balance are basically are they good algorithms that can actually satisfy these constraints and still do get good revenue, do good rewards. And so we prove regret lower bounds and upper bounds. And so for both the cap and tax framework, when gamma is equal to 1, a variant of UCB, which is kind of a standard algorithm, achieves a square root n regret. But for gamma less than 1, it's actually a linear factor of n. And the reason why this is there is because in most each user is like is a separate bandit problem. But then once you're imposing these kinds of global constraints, they're no longer kind of independent bandit problems that you just use your algorithms, and there's some kind of interaction happening across these, and it becomes kind of like a multi-agent problem, and you really have to reason about how to like make this work. Although when gamma is 1, everyone is forced to see the same content, so basically you should back the standard bandit model. But when you have gamma less than 1, there's actually different problems. So that's why you see this change in the regret lower bounds. And then yes, this is what regret is, and then regret upper bounds. And then we also have a similar kind of effect with regret lower bounds, where as gamma changes, you have this once again you have this issue, and you have to think more carefully about how to what the lower bounds are. So our bounds are not quite tight. There's like still some wiggle room there, but proving lower bounds does take a lot of work, and maybe there's some more open questions there and seeing whether these bounds can be improved. But this type of some range of bounds. And so we also analyze a case where you're doing the auditing, what the error is from having to audit the platform, which they're complying with the regulation is only a square root t regret, which basically shows that the longer your time period you have, the more accurate the regulator is able to like assess the platform and impose these constraints. And so this is like still like a somewhat limited work. There's very many directions that could be done to extend this and make this more relevant. So one of them is actually incorporating more about the network structure and like dynamics, because as you could imagine, people are not just staying on the platform, they might leave and come back. There's also like some like social networks going on, and like how does that affect the way the recommendation goes, and how does it interact with the recommendation algorithm. Also, we don't actually explicitly say what we mean in this paper by filter bubbles and polarization. Implicitly, you can kind of say it's like how much overlap do people have in what they're seeing, but maybe thinking about like more like remove from maybe the application, what do we actually mean about by polarization, filter bubbles, and measuring them? It's also something that would be interesting to do. There's also like privacy concerns with the auditing of the platform. You kind of require, you kind of giving your content to the government, which is not necessarily people might be comfortable with that. And so maybe how can we do that in a private way? And also maybe by even adding privacy to the platform, the platform is not able to like target you maybe just as effectively, which might create that kind of remove the role just naturally by incorporating privacy into the recommendation algorithms. And there's also empirical work to actually make tests. We've done some work, but it's not as relevant as we'll like. It's like testing how these approaches do affect things on the recommendation algorithms, and how can we actually translate this like policy recommendations and frameworks that it's like still theoretical, but what are the stakeholders and how can we implement it in real life. Yeah, and also then we don't talk about hate groups, because like if you're doing that kind of thing when you're seeing if there's a hate group, you don't want to actually be forcing people to see kind of like their content. So how do we incorporate content iteration and like those kinds of things into this? So yeah, in conclusion, we propose a flexible approach to disincentivizing for bubbles that adapts to the interest of the platform, and we show that there are scalable algorithms that can do this for you in an effective way. And there's also like fairness concerns that you have to be addressing doing this kind of thing. So thank you. This is QR codes of the paper. Any questions? Yeah. Yes. I can probably hear you.
And I have maybe a clarification question and maybe future work question. So the clarification in this setting, are you modeling profit also in terms of retention time, like how much the user spends on the platform and how that can increase the platform's profit?
So in theory, yes. Like right now, we're not speaking what specific kind of like reward the platform is getting. It could be like as long as it can be measured as a number. But like, I guess some relation to that question is that there's actually a difference between the user's reward versus the platform's reward, and that is one thing that we hope to address. Because like you might imagine maybe there's like disparities in how users rewards translate into platforms rewards, and like there's some issues around that. So I don't know if that answered your question.
Just like, yeah, because I guess it would be a difference if the number of users, say from the platform's perspective, number of users they have in a given day, but also how much time a proportion of users spend on the platform, how much money they derive, I guess, in absolute terms versus in consumption terms, like the same way that YouTube's algorithm just wants you to stay there forever.
Right. So the reward is like abstract, is that you can use measure as like revenue or time watch, clicks, like so we're not like speaking specific reward as long as you can translate some numeric value. But so that's how we're measuring it. I don't know if that makes sense. Yeah, it's like more like abstract sense of reward here.
Yeah. And the second question, this personalization cap, would the platform have incentives to oppose this if you would introduce, say, a competitor in the market?
Right. So yes, the platform doesn't have the incentives. In fact, that's kind of the main problem with the platform incentives are to give you addictive content. And so the way we're thinking of this is like a framework for regulators to impose these sorts of constraints on the platform, because the platform naturally is not going to want to do this kind of thing. So the competitors will also have to comply with this. And so we're kind of like trying to give you like a policy framework, justify by some theory as how you might want to do this in like a reasonable way. Yeah. So yes, the platform will not do this. Thank you. Thank you for your question.
Thank you. Thanks for the great talk. Two quick questions. So your regret is based on the benchmark of this constraint optimization.
Yes.
And then if these constraints are enforced every time period, so for example, as I'm learning, I don't know this P average and things.
Right. So for these two, the tax and the gap framework, they are enforced every time period. But for the audit version, it's in aggregate over a certain time period. So maybe like, so for the other ones, every time you pick a new distribution, you have to obey the constraints. But for the regulator version, we want to make sure that you obey the constraints on average over a year time period. So maybe at any particular moment in time, you may not be obeying the constraints, as long as you obey on average over a time period. So that's where the kind of differences might come into play, that version versus the other two. Yeah.
Is there any intuition that if I first learn your preference and then enforce these things, maybe that is more efficient or better faster? Is there a reason that in this transient period we might not?
Yeah, so we do analyze that, and essentially we don't actually come up with a optimal history dependent strategy, but we do prove that the history dependent strategy is close to one where you just like try and just do the same thing every time, if that makes sense. So you would still maybe do something like with UCBO, like maybe explore the commit kind of thing. You first learn it first and then satisfied. So in theory, there could be ways, but we do show that any way that it does that kind of thing has to be closely to one where you just like do the same thing like kind of consistently over time. Yeah.
Thank you so much.
Thank you.
No, it is. Is it? Give it one more go. No, okay, I can project. Amazing talk, like really, really interesting, and I think that your future directions are super interesting, especially having different values for the users versus the platform, and perhaps even some behavioral attitudes there about not knowing what is best for them. But I think something that would be really interesting to add to this is the existence of multiple platforms.
Mm-hmm.
And like hypothetically, if you had a platform, let's call it Y, that was driving users off of it because it was only maximizing engagement and not what would best for the users, like would they go to other platforms that have different optimizations? And I think like a comparison between platforms, hypothetically.
Right. So like I think that intuitively like something like that could happen, like the dynamic effects, like what if it's polarized by a platform? instead of like on the same platform. Our thing will not be able to address that. And I thought I wrote down the well disparity thing, I guess maybe it's in the poster but not on the slides, but yes, that was something we actually have been trying to think about where like the platform's revenue doesn't, or like utility doesn't match this utility, and like this actual competition thing from that kind of thing. Yeah, I thought I wrote it in. Thank you so much. Yeah. Any other questions?
Yeah, no more questions?
Thank you.